These are the computed problems for Hewitt Chapter 3, and the first one I'm going to do is number 2. That says, what is the acceleration of a vehicle that changes its velocity from 100 kilometers an hour to a dead stop in 10 seconds? So I'm just going to write here vehicle. Now the acceleration is defined as acceleration equals change of velocity divide by time interval so from what is the acceleration of a vehicle that changes its velocity from 100 kilometers an hour to a dead stop in 10 seconds. So the acceleration is going to be 100 kilometers an hour to a dead stop, so I would have to subtract 0 from that. Now technically I wouldn't have to write that down, but I do to show that, well, change of velocity means the difference between the two, and then divide that by the time interval, which is 10 seconds. And when I do that, 100 minus 0 is 100, and 100 divided by 10 is 10. And then the units are kilometers per hour per second, and if I wanted to, I could put the hour and the second together in the denominator. So the acceleration is 10 kilometers per hour per second, and because of course it's a deceleration, and if the car was traveling to the right, that deceleration would be pointing to the left, and if the car would be driving to the left, then that deceleration would be pointing to the right. So a deceleration, where it gets slower, always in the opposite direction of the motion. Okay, the next problem is number 3, which says a ball is thrown straight up with an initial speed of 30 meters per second, so I guess I just call this ball, and initial speed or initial velocity (30 meters per second). How high does it go and how long is it in the air, neglecting air resistance? So they want to know how high does it go, so D equals, or H equals, question mark, and how long is it in the air, T equals, question mark. Now all the equations we came across actually involve time. Since I don't know time yet, I cannot calculate what the distance is yet, which means that I actually will determine what the time is first. So let's do that. So here's the ball that is being thrown straight up at 30 meters per second, and we know something about that ball, as there is no air resistance, that after 1 second it will have a speed of only 20 meters per second, because gravity of 10 meters per second squared slows it down, and then another second later it will have a speed of 10 meters per second, and then another second later it will have a speed of 0 meters per second, and that's actually where the highest point is, so I call this here the peak. Now putting that into an equation would be that v, the velocity, equals gravity times time, and on the way down it would do the same thing, 0, 10, 20, 30. So on the way down it would be 10 meters per second squared times 3 seconds equals 30 meters per second. So by symmetry we figure out that the 3 seconds that I have over here on the way down is also 3 seconds on the way up, which means actually that the total time comes out to 6 seconds. Whoops. 6 seconds. There we go. And the time on the way up is 3 seconds. And that's also what I need in order to figure out what the distance is to the peak. Now that we have the time, we can figure out the distance, and actually that can be determined in several ways. One of the equations says that you take the initial velocity, 30 meters per second, you add the final velocity at the peak, 0 meters per second, you divide by 2, and this is in a footnote, this equation, times the time that it takes, which is 3 seconds. And so the distance, of course, is from here to here, where the velocity decreases from 30 to 0, and that's why I use the numbers that I do. And of course, the time between these 2 points is 3 seconds. So 30 over 2 is 15, times 3 is 45 meters. As I said, now that we have the time, we can actually figure that out in 3 different ways. One would be the average velocity times time, and again this here would be the time up. Average velocity between 30 and 0 is of course 15, and then time up is 3 seconds. Of course that also comes out to 45. I'm not writing that down because I already did here earlier, and you have a choice of 3 equations. And the third one would be to say, okay, 1/2 gt squared, and here this is the free fall equation, so we would actually have to look at on the way down. Again, this is by symmetry, so 1/2 times 10 meters per second squared times 3 seconds squared, and when we look at that, 1/2 times 10 is 5, times 3 squared, which is 9, which is going to be again 45 meters, and I guess I will write that down there, 45 meters. Notice the, mainly to show you what happens to the units. On the last one, we have seconds squared here and seconds squared here. They divide each other, remains meters. On the second one, seconds and seconds divide, remains meters. On the first one, as we add meters per second and meters per second, that is meters per second, and then times a second divides the seconds, which is the meters. Okay, next one is number 5, which says, what is the instantaneous velocity of a freely falling object 10 seconds after it is released from a position of rest? What is the average velocity during this 10-second interval? How far will it fall during this time? Okay, I guess I'm just going to call this problem free fall. And we have some kind of object here that's going to fall down for 10 seconds. So t equals 10 seconds. Well, on the first equation, on the first question, what we have to use is, what is the instantaneous velocity? V equals g times t. So we have 10 meters per second squared times 10 seconds. So we have 100. And then one of the seconds divides, so this second is gone, and one of these 2 seconds is gone, or one of the second squared is gone, which leaves a second in the denominator, and of course the meter in the numerator. So it's supposed to be a nicer looking m. What is the average velocity, which of course is at the initial velocity, so initial velocity to the final velocity, and divide that by 2. So it's going to be the initial one, it falls from rest, so that's 0, plus the final one is 100 meters per second divided by 2, which comes out to 50 meters per second. Of course, we could have just looked at that and figured that out. How far will it fall? D equals 1/2 gt squared. So that is 1/2 10 meters per second squared times 10 seconds squared. So that is 1/2 times 10 is 5, times 10 squared is 100, so 500. All the seconds are canceling, and we come up with 500 meters.